Anyway, so let me talk about this problem. So a particle of mass 1 milligram and charge q is lying, oh, 1 milligram and charge q is lying at the midpoint of two stationary particles kept at a distance 2 meter. So there is two stationary particle which is kept at 2 meter. Okay, so let me write this thing. So this is two stationary particle and they are kept as 2 meter, and there is one particle of mass, this is written like this. Now when each is carrying same charge, so these are carrying same charge q. Okay, if free charge particle is displaced from its equilibrium position to like this, so this is dot 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 dot, so this is also q, displaced from its equilibrium position through a distance x, the particle executes SHM. So how can you say that SHM? First, SHM, the condition for SHM is the acceleration of that particle will be minus omega square x. So acceleration will be proportional to the displacement and negative of that. Okay, so that will be the equation of SHM. Now this is, so how we are gonna solve it is, let's say this is D, then this will be D. Now from this is X. So what will be the force? Means from midpoint it is displaced from by X amount, right? This is D. So D is equals to 2 by 1 meter, 2 by 2 meter. So this will be 1 meter, right? So what will be the force on this displaced particle? Net force on the displaced particle will be net force on the displaced particle is equal to, so for this will be like this, and for this charge this will be like this, so in opposite directions. So for that this will be how much? K, so let it be like 4 pi epsilon naught, otherwise it will q square by 4 pi epsilon naught d plus x whole square minus q square divided by 4 pi epsilon naught d minus x whole square, right? This is the force. So if you do the calculations, then q square by 4 pi epsilon naught times d plus x whole square into d minus x whole square, and this is d minus x whole square minus d plus x whole square, right? So then it becomes minus, so from here it will be minus 2 dx, from here 2 dx, there is minus of minus 4 dx. So q square, so this will be minus q square times 4 dx divided by 4 pi epsilon naught d square minus x square whole square, right? Now here it is easily said that x is very less than 1 meter. That means, so since x is very less than 1 meter, that means x is very less than d. So here then d square minus x square whole square will be very close to minus 4 dx q divided by 4 pi epsilon naught d to the power 4. So that makes minus 4 q divided by 4 pi epsilon naught d cube times x. So now this term is constant, right? So now force, if that is the force, this is the force, then acceleration a will be f by m. So that means minus 4 minus 4q divided by 4 pi epsilon naught m d cube times x. So we can write that as omega square x. So this is the SHM equation. এটাই তো তোমার SHM equation, right? So then omega square is the angular frequency omega, then it will be, just a minute, there is some error. So here then this will be omega square. So omega square will be how much? 4q divided by 4 pi epsilon naught m dq. So what is q value? We know the q value. Q value is 10. Q square is 10. Okay, so I think so. So this will be q square, q square, q square, q square. So this will be q square. So then first 4 for q square, this is 10. For 1 by 4 pi epsilon naught, this is 9 into 10 to the power 9. For 1 m is 1 milligram, that is 1 into 10 to the power minus 6 kg. d cube is 1 meter, so d cube is 1. So this will be something rad per second, right? This is SI in SI unit. So then it becomes this is 36 root over of 36 times 10 to the power 16 rad 10 to the power 16. That means in the root it will be 10 to the power 8 rad per second. So 6 into 10 to the power 8 rad per second. So that means 6000 into 10 to the power 5 rad per second. So this will be 6000. So this will be 6000. Okay. So the main concept is when this is displaced from its equilibrium position, which is in the middle, then there will be some disbalance in the force and there will be some net force. So if we calculate the net force, then we have seen that this unbalanced force follows this is a simple harmonic motion equation, and from that we will calculate the angular frequency. Understood, Doivik?
Yes, sir.